Welcome to my video series on how to hack electronic toys. In this first episode, I'm going to show you how to do a really simple hack on this guy right here. He's a chicken Elmo, and it's going to be a lot of fun. So let's get started. So this is a chicken Elmo. He's one of the simpler Elmos, doesn't do a whole lot. You can get him at a thrift store for a couple of bucks, but we're going to do a really simple hack on him. So first of all, let's see what it actually does. It has two switches down here on the feet, and depending on which one you hit, it does something different. So let's just see what happens. Here's the right foot. Just a really simple head turn and noise. And the left foot, a little bit more involved.
Come on, everybody, let's do the chicken dance with Elmo. Elmo wants to be a chicken, Elmo wants to be a duck. Clap your hands like a chicken, clap your hands like a chicken.
So now you've seen what this guy can do. Next question is, what exactly are we going to do for our hack today? Well, since this is a simple hack, we're going to just do something basic, which is instead of having to press these buttons physically to activate these sounds and we're going to just use it electronically. So to do that, we're going to use an Arduino, which is a tiny little computer, and we're going to hook up with some electronics so that we can trigger those sounds anytime we want. So again, instead of having to press something, then we'll just be able to trigger it from our Arduino, maybe when we get an email or a Twitter message, or if someone likes our Facebook post, we can have this Elmo do his stuff. So that's what we're going to do, and now let's see what the next steps are to make that happen. Right. So now that you know what kind of hack we're going to do, where do we get started? Well, first of all, let's just have a quick overview of kind of how these Elmos are put together. A lot of the Elmos are pretty similar. They'll have a kind of a hard plastic thing right here in the middle, and probably a later hack will actually open this up and do stuff to the insides. But here, if you notice, this one, the buttons are down here on the feet. And if we look at the bottom, this is also pretty common with Elmos. You'll have the batteries and other electronics and stuff down in the feet as well. So in this case, since our switch is right here and batteries down here, so we're probably going to be able to just do everything we need under these feet. So first thing we want to do is unscrew all these screws and see what's in here. Okay, so let's take our screwdriver and let's first open up this battery compartment. All right, there's our batteries. Always a good idea, take out the batteries when you're going to do, before you start hacking on them or anything. And that made a lot of noise. Also, you can see there's 4 more screws here, so let's go ahead and take those out as well. Okay, we've got our screws out. Always remember to know where your screws are, keep them together. And now let's just take this bottom off and let's see what we got in here. All right, so first off, you can look at these two. These are the ones that are coming from this little battery compartment here. So, those are just your power, plus and minus leads, and we'll talk more about that in a little bit. And then up here at the top, you can see this is where the bottom part of that button is. And we can sort of peel back a bit of this. And now you can really see the button in there, and you can see these 2 yellow wires coming out of it. So generally these push buttons, they're going to have 2 wires because it makes like a little circuit, and that's where we want to do our stuff. So we can pull these wires out a little bit. Now you'll see they're taped at the moment because that's where I'd cut them apart earlier and I put them back together to show you how to do it. So these 2 yellow wires go up through the leg and all the way to the brains of the Elmo, as well as the power. And this is where we want to do our hack. We've opened it up, you've seen the wires, you've seen how the power runs for this leg. Now let's talk a little bit about how we're going to do this hack. We want to be able to simulate this button pressing. Now physically what happens when I press this button is it makes a connection internally that makes these two yellow wires connect together. That sends a signal up to the brain of the Elmo to trigger the animation and sound. So in order to trigger this electronically, we really need an electronic switch. There's a few things we could do, but for this hack, we're going to go really simple and use something called a transistor. So this right here is a transistor. Now, this little guy is pretty good at being a switch for us, electronic switch. It has some other things it can do, but for us, we're just going to use it as a way to get two lines connected together, just like this physical switch does. Now, if you'll notice a couple things on this, it has a flat side to it and a rounded side. Here on the back, you can sort of see it if you look at it from the top. And the other more important thing about this transistor is that it has three legs. And the basics are that you have this leg on the left is our collector. So that's where power should come in from. The middle leg is what's called the base, and that is the leg we're going to use to trigger the switch on and off. And then the third line is called the emitter, and that's where the power is going to go once the base is triggered. So let's also look at this on the whiteboard just to make it clear on which things are which. All right, these are two circuit diagrams. Now we're not going to diagram the whole entire Elmo because we haven't opened them up to see what else is in there and how things are connected. So for now, just know that these two lines here are the two lines that go back to the brains of the Elmo, and this represents the switch. This is how you draw a switch in a circuit diagram, and when the switch is pressed, the connection's made and signal can go through. So on the right is how you would draw a transistor. And again, remember that our transistor is an electronic switch, so you still have the two lines, and then when you apply a signal on this base, then the current flows from here and goes up there through the emitter. And that's what we're going to do here. Now, we've got our transistor, and this is going to be our electronic switch, and we're going to connect both sides of the transistor to the yellow lines we saw on the Elmo. But we need something that can send a signal to the transistor to turn it on and off. For that, we're going to use an Arduino. So this is an Arduino. This is a very tiny computer, and a lot of times people would call this a microcontroller because it's really compact. It only can do a certain number of things, but it's also really easy to use. As you can see, it's got a processor on it, which is here, and it's got a bunch of connections that we can use to send signals on and receive signals. So this is going to be the brains of this little hack, and we're going to use this to turn on and off the transistor, which in turn will turn on and off those animations on the Elmo. So let's get this stuff connected up. So to create a place where we can connect all of our stuff together without soldering it or doing anything permanent, usually you'd use a breadboard. So this is our breadboard, and it's really cool, just is easy to connect stuff with it. So first thing I'm going to do is put the transistor in there. So always make sure that you're kind of putting this in the right way. You can see that it has a flat side to it, and again it has that round side. So if you just hold it like this with the flat side pointing towards you, and then just shove it in some of these pins. Easier said than done. Okay, there we go. So now we've got the transistor in here, and we've got our three pins. And remember, you've got your collector, your base, and your emitter from left to right. All right, now we want to connect from the transistor, we want some way to connect to the Elmo. So I'm going to use one of these little clips. So it's got like a little clip on one side and a stripped off piece of wire on the other side. And that I'm going to shove into one of these holes right below the collector. Okay. Now on a breadboard, if you can look real close here, so you notice that I put this wire, this red wire, right below the transistor collector. So everything on that line from top to bottom there, they're all connected together. So if I were to put something else below this red wire, let's say I've got this black wire here. So if I put that here, it would also be connected to that part of the transistor. So all these lines are connected. Now in this case, what I want is I want this other side on the emitter. So I'm going to plug that in there. And now I've got that guy ready to go with these little clips. And finally, I want a place to connect the Arduino. So I'm going to plug this blue line into the middle. And again, you can plug it anywhere on this, vertically. And then the other side, let's plug into the Arduino. Get our Arduino out here. And for no particular reason, I'm going to plug it into port 8 or pin 8, whichever you want to call it. All right, so we've got Arduino pin 8 going over to the transistor base. We've got this red line connected to our collector and black to the emitter. Now let's get the Elmo connected and continue on. All right, so here's our Elmo again. And remember, it's these two yellow wires that we want to connect our transistor to. And again, I've already cut these earlier when I was setting up the video. So what you want to do, take your wire cutters or something similar and just cut the wires. Through the magic of video, I'm going to just disconnect the ones I've already taped up. And ta-da, there we go. So now we've got all these disconnected. All right, so these two wires are the ones that go to the switch. Remember, our switch is under there. So for now, let's just kind of hide these so that we don't get confused, because we really don't need them anymore. The switch is now gonna do nothing. So what we want are these two. And for now, again, we're just kind of connecting things temporarily. Later we can solder it all together and make it all look good and stuff, but it's always a good idea to just sort of use the simple and not permanent ways to connect. So we're going to connect the red wire up to one of these yellow ones and the black one to the other one. For now, this doesn't necessarily matter, but we'll see later that we might swap these, but for now that's okay. Just pick one and red wire on one of these and the black on the other. And again, make sure that you're connecting these to the wires that are going up the leg back to the brains. Okay, we've got our little circuit. We've got our Arduino transistor connected to these wires. We're going to act like a switch. Now we're going to write some code for this Arduino here in a minute, but we've got one more thing we need to do. And this can be confusing when you first start out hacking, because you think that this is enough to make the switch work. Just by sending the signal to the transistor, that whatever is coming down one of these lines will go through the transistor and back up that line. But this will not work as it stands, because there's one problem. And to explain it, I'm going to go back to the whiteboard so you can understand a little bit more about how the circuit is working, and one more thing we need to do. So this is a really simplified circuit diagram, just changed a little bit. But what you've got is you've got your Elmo, and he's got his brains in here, And the Elmo has its own power. So he's got his own batteries, and it's usually, you would see VCC for the plus side and ground for the minus side. And so he's got that. And then he's got these two lines that go to the switch. All right, and now we've replaced that with a transistor. So the transistor has another line go into the Arduino, and the Arduino also has its own power. So it's not connected to the power for the Elmo. It's going to run off its own batteries and do its thing. And it also has its own ground. So what happens in a transistor is, and this is oversimplified, so if you're an electronics engineer, please don't yell at me, but simplified, you've got a signal that comes down here, and once the Arduino sends its signal, then these two signals both will travel down this negative line. So you might think that only the signal that's coming down here will go back. That's not really true. Part of what comes out of the Arduino also goes back. So now we've got stuff, and stuff by I mean, electrons and electricity, if you will, coming out of the Arduino and going through here into ground, and that just doesn't work. So it's just not going to let you do that, because circuits need to be circular. So they need to kind of have something common where power can go to. So the answer to this is really quite simple, but it's just something that will trip you up if you don't do it. So really what we want to do is we just want to make sure that the ground from the Elmo is attached to the ground to the Arduino. Now what happens is when the signal passes up this way, then it can go both directions, and it will actually work. Otherwise, what will happen is you'll send this signal over here from the Arduino and nothing will happen. This Elmo will not be triggered because it has nowhere to go. So this is all we got to do, but it's a really important step. So if you remember earlier, we were looking at this, and we pointed out that there's actually a flow here between these. So if you look at the back, you'll see on this side it has this little metal tab, and if we were to open up this plastic, we would see that these two sides over here are actually connected. And if you look really close in there, you'll see it. So these are connected, but these are not. And let's just take off this tape and pull that back a little bit. And now you can see that these actually have separate connections. All right. Now, if you kind of use your battery as a guide here, all right. So we can see we have a positive to negative, and these are connected. So if we put in the other battery just for reference, oops, then we're going to go positive to negative. So if you look at this side, now we know this is positive and that's negative. And also we could say this is our VCC and that's our ground. So if we turn this over, and remember this is ground, that means this black line here is ground on the Elmo, and this pink line is power. In this case it's 3 volts. Again, we don't know what else is going on over there. We don't really care right now. But for over here, this is going to be ground, and that's going to be power. So we want to connect this ground over to the Arduino's ground. So I'm going to use another one of these little guys and connect it to this terminal, which is metal. So it should make a decent connection. And then put the other end to the Arduino. And now we're starting to get wires all over the place, but that's okay. That's part of the fun. All right, so try to zoom in here and show you where these lines come in. There we go. Over here on the left-hand side, you can see there's a voltage in, and then right above it, there are 2 places where you can connect to ground. So we'll just put this in one of those. very badly. There we go. All right, so now we've got ground over here, and it's connected down on the Elmo to ground down there. And again, that one's a little loose, but it will be fine for now. Okay, that is our entire circuit. That's all we need to do, like, from the electronics point of view, to get this to work. So next we need to start looking at the Arduino and how to write a program that will turn on this pin 8 and send a signal down whenever we want. All right, here we are in the Arduino IDE on my computer. Now this video I'm not going to go over how to set up this Arduino IDE and go into depth on the programming language, but we'll just give you a few basics to get this particular hack done. Later videos we can go into more details. So for this particular sketch, what they call it in Arduino terms, there's a setup function, and in this setup function we're going to just tell the Arduino that our pin 8 that we got connected to our transistor is an output pin. So the Arduino can actually send a signal out that thing. And then the next function is this loop function, which will happen over and over again. And in this one we're going to first call this delay function, which will create a little 3-second delay when we first start up. And then more importantly, these next three functions, first of all we've got this digital write, and it has two parameters. The first one is the pin number, which is 8, which is again where our transistor is connected. The second parameter is high. What that does is signals to the Arduino to actually send a current signal down that pin, and again in this case it goes to our transistor, which completes that circuit so that the Elmo's brain can think that the switch is pressed. Now on the Elmo itself, that's a momentary switch, so those you would press down and release, and that's what triggers the actual sound to happen. So we want to do the same thing, and to do that the next thing we'll do is call another delay for 500 milliseconds, and then another digital write, and we're going to still be on pin 8, but we're going to change the second parameter to low. And what that does is turns off that pin. So we're going to turn it on with the first digital write, wait 500 milliseconds, and then turn it off. So that simulates you pressing down and letting go. And then lastly, we've got another delay of 2 seconds so that when we loop, then we'll have like a total of 5 seconds delay in between each time we're pressing. So this code here will just continually keep pressing the button over and over every 5 seconds. This is enough to at least tell us if everything's connected correctly and our hack is working. So now let's give it a try on the Arduino and see what happens. All right, I've got the Elmo hooked up, I've got the Arduino. I've already downloaded the code to the Arduino. Right now it's powered off. So what I'm going to do is just plug in the Arduino, which will give it power from the computer, and it should run that code that we just downloaded. So keep an eye on that guy, and he should, after a few seconds, start doing his thing. And now you can see that we're triggering that button just from this Arduino. Every few seconds it's going to keep triggering it. So our hack has worked. All right, let's recap what we've done. We've replaced this Elmo's physical switch with an electronic one. So now we can trigger that switch from an Arduino, a Raspberry Pi, or really anything that can send a signal to that transistor. This is a hack you can use on all kinds of toys, with ones with switches. So if you've got a momentary switch like this or a flip switch, you can use this kind of hack to make the toy do something that it wasn't really originally intended to do. Next episode, what we're going to do is make this permanent. So we're going to solder everything together, put the transistor inside the Elmo. We're going to change this foot here and add a transistor switch to it as well. And we're going to add a motion sensor so that when someone walks by the Elmo, it'll do its animation and hopefully scare the crap out of them. And that's all we're going to do this episode. Hope you've enjoyed it, and we'll see you next time. If you've enjoyed this video, then please hit the subscribe button or like the video, leave a comment below. can also go to our website, repairward.com. Also, you can look in the notes of this video to see all the links to parts and the code. So basically everything you would need to do this hack yourself, except for, you know, the Elmo itself, which you can find at the thrift store, or you can probably find one on eBay that is just like that one. So again, hope you'd enjoyed it. We'll see you next time.